All right, Chapter 1, Section 4, Complex Numbers. If you remember, these are the problems where we end up with something like 2i or 3i, something involving I. That I represents an imaginary number, a number that is not real, but we can still manipulate these types of problems and still get an answer in terms of I, which would be an indication that our graph does not pass through the x-axis. And that's one of the practical uses for I. All right, the imaginary unit I is defined as I, which really equals the square root of -1. And so I squared equals -1. Because remember, when you square a square root, the power and the radical, they're inverses of one another. That would leave you with a radicand. So, on this part of the note sheet, we're going to talk about I squared, I cubed, I to the fourth. We're going to take it a little bit further. And you might see problems like this on the SAT or some other kind of standardized test. I'm going to actually ask you to then refer to the last page of your notes. If you flip it over, the back is completely, like there's nothing on page 4, if you will. But we are going to write on that. And we're going to base it off of, you know, what we're going to do here in this little box. So again, I is equal to the square root of -1, right? Because the square root of a negative is not real, and so this would be an imaginary number. Now, I squared would really mean radical -1 times itself radical -1, which equals radical -1 squared, and that's going to equal -1. I cubed, well, do you agree I cubed is really I squared times I? Well, look, I squared equals -1, and I equals the square root of -1. And so, since this is I, this is -1 times I, which is -I. Okay, all I'm doing is doing this long form and just substituting in, right? I cubed is really I squared times I. And we know I squared is -1. We just saw that up here. You know, I squared equals -1, so I substituted it. Times I, well, I is radical -1, so this becomes -1 times I, right? Because square root of -1 is I. And that's -I. I could have just went from here to here, I suppose. I to the fourth. Well, I to the fourth, do you agree that we could rewrite this as I squared times I squared? And the first I squared equals -1. The second time I squared still equals -1. And -1 times -1 is +1. We could take this a step further, and I could figure out what I to the power of 5 is. Well, I to the power of 5 is I to the fourth times I. I know I to the fourth is 1, and 1 times I is I. And I can keep doing this again and again and again. I'm going to do it one more time. I to the power of 6. I could think of this as I to the power of 4 times I squared. Well, what's I to the power of 4 equal? I to the fourth is 1. I squared is -1. And +1 times -1 is -1. And why do we keep doing this? Because I want you to see a pattern. I'm going to extend this up here, and I'm just going to write the I up here. Okay, I equals radical -1, which still equals I. And you should see a pattern that first we have I, then -1, then -I, and then +1. And the pattern will start over again with I and then negative 1. And so it would make sense that I to the power of 7 is negative I, and I to the power of 8 is positive 1. And it will continue like this in a cycle of 4, because every 4 i's being multiplied together equals a positive 1. And so that brings us to what we're going to talk about on side 4 of the notes. So either get a separate sheet excuse me, of notebook paper, or put on a separate sheet of lined paper. It's up to you. Whatever you want to do. We're going to write here that this pattern of I repeats in cycles of 4. Okay, so it's I, then negative 1, then negative I, then positive 1. Okay, this is I to the first, this is I squared, this is I to the third, this is I to the fourth. I to the fifth would be I to the sixth, negative 1, I to the seventh, negative I to the eighth, 1, I to the ninth, I, and so on, and so on, and so on. It keeps repeating. Now, why are we doing this? Well, because I want you to simplify, or be able to simplify, something like I raised to the power 623. And if you know that I repeats in cycles of 4, this is not so bad. So we're going to write, so I to the power of 4 equals I to the, what you're going to do here is take your exponent and divide it by 4. So I'm going to take my exponent 4 and I'm going to divide it by 4. Why? Because it repeats in cycles of 4. Okay? So that is equals I to the power of 1 with a remainder of 0. Okay? So I'm going to take the exponent on I, the 4. And I'm looking for the remainder. The remainder is 0. So, you know, if I take this 4 over 4 and I divide it, I'm going to get a 1 with a remainder of 0. That remainder is what actually sticks back on I, right? Because again, this was 4 over 4 equals 1 with a remainder of 0. So this comes out as I to the power of 0, which equals 1. Isn't anything to the 0 power 1? All right, well, let's do this one long form, and you'll see I'm going to do it 2 different ways. So let's do an example. Simplify I to the power of 15. All right, I could do it this way. I know that every 4 i's is going to come out as a 1. So this would be I to the 4th times I to the 4th. That's 8, 9, 10, 11, 12, 13, 14, 15. Do you agree? This I to the power of 4 equals 1. This I to the 4th equals 1. This I to the 4th equals 1. This is I cubed. So this is equaling I cubed, but I know what I cubed is. I cubed is negative 1. Right? 1 times 1 times 1 is this, and this is really I squared times I, and I squared is negative 1. So this thing equals negative I. But I could think of it like this. I could take I to the power of 15 and say, I'm going to take the exponent 15 and divide it by 4. 15 over 4 is 3 with a remainder of, right, 4 times 3 is 12, remainder of 3. the remainder is now what gets still stuck on I. And that's what this says up here. So I cubed is negative I. Okay, this way is a whole lot quicker, and you can use a calculator than doing this. I mean, you certainly could do that. Now, let's get on to some where we are going to use a calculator. So, an example is simplify I to the power of 25. So, I know this happens in cycles of 4. You know, this is I times itself 25 times. But every 4 i's is going to come out as a 1. So I'm going to take 25 and divide it by 4. I don't think I need a calculator for this one, right? 6 times 4 is 24. Remainder is 1. So from this is what I'm interested in. From the remainder, I know then this equals I to the power of 1, which equals I. So I to the power of 25 simply equals I. Example. Excuse me, simplify. This time we'll do I to the power of 54. Okay, we know the cycle is 4. So take the exponent 54 divided by 4. Well, maybe you want a calculator this time. I don't know. So let's take 54 and divide it by 4, and we see it's 13.5. Ooh, 13.5. 0.5 means how much? That's half of how many? Half of 4. Yes? What's half of 4? 2. So this is 13 with a remainder of 2. 2 out of 4. Okay? You know, when you use the calculator, you're only going to have 4 things come out, okay? 4 things. It's either going to be a whole number, no remainder. It's going to be a 0.25, remainder is 1, right? 0.25 would be 1 out of 4. 0.5 is 2 out of 4. And 0.75 would be 3 out of 4. Those are the only possibilities. It's either no remainder, 0.25, 0.5, or 0.75, indicating my 0 remainder, my 1 remainder, my 2 remainder, or my 3 remainder. Remember, I can't have a 4 remainder because 4 is going to divide it again. Excuse me. So 13.5 is 13 with a remainder of 2. So this becomes I squared, and we know that I squared equals negative 1. Okay, so I to the power of 54 equals negative 1. All right, example. Simplify I to the power of, this time, 64. Why don't you go ahead and try that one on your own? All right, hopefully you got the calculator out and you did that. I'm going to take the exponent 64. I'm going to divide it by 4. And 64 divided by 4 is 16. You could do that on the calculator. 64 divided by 4 is 16. Notice that's 16.0. The remainder is 0. 16 remainder is 0. So I to the 64th is the same as I to the power of 0, and anything to the 0 power equals 1. And one more. Simplify. All right. I to the 623rd power. So why don't you pause the video and you try that one. All right, hopefully you pause the video. And now we know the rule is take the exponent 623, divide it by 4. Use your friend calculator to help you. 623 divided by 4 is, look at that, 155.75. That means the remainder is 3. So I to the 623rd power, really, when I simplify it, is I cubed. And I cubed is really I squared times I, or negative I. Okay, so I don't know. I don't think it's that terribly difficult if you can remember that this cycle of i's repeats in a pattern of 4. Okay, so you're going to take the exponent. Take the exponent on I, divide by 4, keep the remainder on I, and simplify. You know, when you have this one here, 155, well, that means 155 groups of 4 i's are going to come out, right? 155, 155, 155, 155. And then you're going to have 3 left over that can't get roped into a group of 4. Okay, so again, you know, I would have a remainder 1. Negative I has a remainder of 2. I'm sorry, 3. Comma. Okay, and those are my 2 i's, because remember it was I, negative 1, negative I, positive 1. So I probably should have done that differently. But I've got my 2 i's here, positive and a negative I, and then I want my 1s. I want a negative 1. Negative 1 would be a remainder of 2. And then a positive 1. Remember, that's a remainder of 0. Remember, because every 4 i's comes out as a 1. Okay? So, for possibilities, you know, if the remainder is 1, this is going to be your 0.25 remainder. Remainder of 3 is your 0.75 remainder. Remainder of 2 is your 0.5 remainder. And then, of course, the remainder of 0 is just, you know, is a whole number. Okay, 0 remainder. So you could try that, play around with that. I'll be honest with you, I don't do much in this course with this I raised to some astronomical power. But you may see this on a standardized test. I've had students tell me that they've seen it on the SAT. But it's kind of interesting. Kind of sets you up for modular arithmetic, which is something else that we won't get into, not in this lesson anyway, not in this course. So hopefully you find that intriguing. We're going to go back to side 1 of the notes, and we're going to do side 1 and part of side 2, and then we're going to end this video lesson. So, back to side 1. After we now have done a little bit of an investigation on I. Using the imaginary unit, we can express the square root of any negative number as a real multiple of I. For example, the square root of negative 25 could be thought of as the square root of negative 1 times the square root of 25. This part here is real. Root 25 is real. That's 5. This is my imaginary part. And so we say this is equivalent to 5i. Complex numbers. Well, complex numbers are the set of all numbers of the form a plus b times I. A and b are real, and I is the imaginary unit. Now, folks, it would be improper for you to write something like 2i plus 6. It has to be 6 plus 2i. The imaginary part always comes second, so I'm a stickler for that to make sure that you have it in the right form. Okay, now we're going to do what we did for some basic polynomials, and we're going to combine like terms. We're going to add or subtract real parts and imaginary parts. In other words, I'm going to have a quantity like 5 subtract 2i. And to that, I'm going to add the quantity 3 plus 3i. Folks, this is not FOIL. This is addition. And so I'm going to add the real parts, 5 and 3. And then I'm going to add the imaginary parts, which is negative 2i plus 3i. And when I add 5 and 3, I get 8. And negative 2i plus 3i is plus I, or plus 1i. Folks, this is a plus bi form. Okay, the imaginary part comes second. All right, one more. 2 plus 6i. This time, subtract quantity 12, subtract 4i. We do have to distribute a negative right here. So this becomes 2 plus 6i. Subtract 12, add 4i. Put your real parts together. Negative 10, your imaginary part, second, negative 10 plus 10i. You can leave it like that. I know we don't like leading negatives. I mean, if you wanted to factor out the negative, then you could write it like that. But don't switch these two, because then that would not be a plus bi form. Okay, we want the real part first, and then the imaginary. Okay, so you could write it this way, or if you have that desperate need to factor out the negative, then you could do it that way. Okay, if you have any questions, or even if you have questions on something like I to the 623rd power, post a comment or ask in the discussion. Online e-learners, I'm getting a little concerned that not many of you are asking any questions at all. Remember, I'm here to help you. I can't help you unless you tell me. All right. Side 2 of the notes, multiplying complex numbers. And here's where we are going to use this kind of stuff in this course. You have to use the distributive property or the FOIL method, and each time you see an I squared, you need to replace it with negative 1. Why? Because I squared equals negative 1. Okay, we don't want to have any expressions that have an I squared. So, our first example is 7 times I multiplied with quantity to subtract 9i. Okay, this is distributive property. I'm going to multiply these two together. Okay, 7 times 2 is 14. Don't forget about I. Now we're going to multiply these two. Positive times negative is negative. 9 times 7, 63. I times I squared. Just like if that were an x times x would be an x squared. And I times I is an I squared. Every I squared equals negative 1. So we have to simplify this and replace the I squared with negative 1. This now becomes positive 63, which I'm going to move to the front. And then plus 14i. Final answer. And again, it's got to be an A plus BI form. Okay, so make sure you're putting your I stuff in the back. All right, one more. It's going to be FOIL. 5 plus 4i. Multiply with quantity 6, subtract 7i. Okay, we're going to FOIL. 6 times 5, 30. These two. 5 times 7, 35. It's negative. Don't forget about I. The middles. 6 times 4, 24. It's positive. Don't forget about I. These two. 4 times 7, 28. It's negative. I times I is I squared. Folks, everywhere you have an I squared, you replace it with -1. I'm going to combine these two in the middle. I'm going to write 30. -35i plus 24i. They are like terms. So 24, 30, 11. That would be -11i. And this actually turns out to be -28 times -1, which is actually +28. And when I add 28 to 30, I get 58. That has to go in the front. 58 minus 11i. It's got to go in the front because that's the real part. The imaginary part comes second. A plus bi. So, that's it for this part of the lesson. You could, goof around a little bit with the I to the large powers and maybe somehow, I don't know if you can do Google search or just practice the problems that we did. All you do is take the exponent and divide by 4, and you're looking for a remainder of 0, 0.25, 0.5, or 0.75. All right, if you have any questions, you know what to do. Contact me, post on the discussion, or ask in class, or ask in a Google Meet. Have a great day.